Do you still make your LED key fobs in this method? This is a simple method using a 25mm Forstner bit, LR44 button cells and strips of Tektronix tape. The LED has to be soldered in place here, and this can lead to a few problems which I'll show you. Going to insert the batteries first of all. The batteries have to be separated by an insulator. I'm going to use a piece of the back of the strip of Tektronix tape that I've used to place on the bottom of the LED, and I'm going to put a piece of foam at the front to stop movement of the batteries of the cells. I'll test it first before I place the top on. I'll just use, and I can see that the LED is working. Now I'm going to place the cap on place. Now this can lead to issues because it's sometimes difficult to center this up where it's going to make proper contact with the two cells. Now, in this case you can see an issue. The LED is on all the time. Now that's going to lead to some messing about and to try and find out why the LED is coming on. I'm going to show you another method of making this, which I think is much simpler. Some of the problems you can get with this original method are that the batteries, the LR44 batteries, tend to be quite thick, which means the hole that you need to make with the Forstner bit needs to be thick also, needs to be deep. Now, I can see even by looking at this that the surface is going to be very close to the top of that, meaning that this here might actually be pushing directly down on the top of the batteries at all times, making a circuit constantly rather than only when it's pressed. Another problem you can have, of course, is this is where the tape at the back has not been cut off neatly, and it means that it can come up at the back and can actually short circuit one of the cells. Another regular issue is this: sometimes when pupils are soldering these, the tags are left very long, or else they're soldered too far back and they actually come in contact with the cell. The cells we decided to use were LR43s. Now, if you notice the thickness between the two cells, the LR43 is much narrower, thinner than the LR44, which means that it will fit much neater into this and a shallower hole can be drilled in this. As well as less drilling, it also is less chance of penetration through the second layer. Another benefit of using LR43s, they're about half the price of the LR44s. Obviously, because the size is a smaller cell, it'll have a smaller capacity, so it won't run the light as long. Another problem that we have with this circuit is that often when the children put the circuit into their pocket, it's pushed against something and this happens. Now you can notice where we have folding in the bottom of the Tektronix tape, which will automatically short circuit the battery. Now this cannot be repaired without the surface, the cover being taken off and replaced. I'm going to replace this circuit with one that we have developed in St Mary's. Now, we have noticed many problems over the years making this type of circuit. A lot of the time it is resolved by the lab technician spent many hours afterwards repairing circuits. we come up with this design, which is made from Fomex and is made on the CNC machine. And we started off making one, but you can make 50 or possibly 100 at a time. So you could make them for your whole year group in one session. The first thing we do is we're going to remove the existing circuit. Now largely this, maybe you can use it for something else, but it's not much good because the legs are quite short. I'm going to take a little piece of Tektronix tape, not that piece, and I'm going to place this at the bottom of the circuit. Now this piece will run across the bottom of the circuit like so. Now you don't have to be too careful with this. The beauty about this device is it exactly fits the two LR43 batteries, so the students can place these themselves. So I'm going to place these in place and let you see how it fits. Now many people use standard LEDs, but probably more people use the super bright LEDs. Now I'm going to use this one to show you the example. There's a little lip around the base of the LED which sometimes has to be filed away in order that the LED will sit in for you neatly. I've already filed away part of this one so that it should fit in nice and neatly for me. So I'm going to place this into the circuit like so, and I'm going to fold the two legs up. Now you're probably thinking, well, that LED is not going to stay in place because it's no longer been soldered, but that has been taken care of by our circuit. So I'm going to fit this in place. It should fit neatly. And there we have it. And the two legs are going to come down. As you can see from the circuit, the LED is prevented from coming backwards by this small piece of plastic here which stops the LED moving back. There's also two channels cut to facilitate the legs. Now as you can also see, at the moment the legs are too long and those will have to be trimmed down. So I'm going to trim this one. You can see it's still too long, so I'm going to trim it slightly more. And I'm going to trim the second one here. Okay, the channels should keep the legs in place, so there's very little extra to do. Now because this was made for a circuit which was using the original LR44 batteries, the cells are quite the hole is quite deep. I may have to put in some circles made from card to take up the difference. Now, but if you notice, if I press down, the LED does work. Now I'll just try this first of all. Now in this original circuit, I'm going to have to remove the conductor, which is no longer required. So I'm going to take that off. Now this is one mechanism which is useful, that you can just use rather than a disc. You can just use card. Now I'm going to replace the lid onto the existing shape, trying to match it up. And as you can see, when you press the button, your LED works. We have found 100% success with this, and we think that it is extremely good when you're using it in this project. This device has made life very simple for our first year key fob project. This is a quick screenshot of the design on Texoft 2D design of the inset that's made for the key fob. We used a 2mm cutter, and it cuts a perfect shape out of Fomex. We used 3mm Fomex. I have set this up to show that we can get 50 from a small piece of Fomex, which is 23 centimeters by 15. Now obviously I'm going to make this smaller so that you can see the actual size of the sheet. So that would be the actual size of the sheet. So it doesn't actually take up a full sheet. You could easily make 100. The bed on the machine that we have is 30 centimeters by 30. So you could easily take one full sheet and fill this area here, of course, and go take it up as far as this. So you could possibly get maybe 120 out of that. Just to summarise then the benefits of using the insert. They come off the machine and they look like this. You can see they're quite furry, but you can clean that up with a ruler or very quickly a knife, but you can see it comes up very clean, and it takes literally seconds to get that clean, and when it does, it cleans up to a very nice edge. So that literally will clean off very, very easily indeed. So summarising the benefits, basically you need, first of all, to make this project, you'll need Texoft 2D Design version 2 installed on your computer. You'll need some sort of CAD/CAM machine. We have a Roland MDX40. You'll need a sheet of Fomex. I used a 23 centimeter by 15 centimeter sheet. You could theoretically just copy and paste the file and double it, and you could fill the whole 30 by 30 sheet. I used a 2mm cutting tool. You could theoretically use a 3mm cutting tool. I haven't done that. I don't know if that would, how that would pan out. It seemed to be as if it would work fine. Double-sided CNC tape, and to make this you would need a piece of tape under each line, so they're constructed that way. So you would need a piece of tape under each line of these patterns as you're going along. And basically you need the pattern, and if anyone requires the pattern, I'll put up my email address. You can send me an email. I'll send the file on to you. So just to summarise the benefits, you're making a far more reliable product. Pushing the LED back now is impossible. There's no soldering required in the project whatsoever, so there's no technician support required for setting up soldering stations and that sort of thing. It will cut a week off the length of the time it takes to make the project. There's no technician required in repairing malfunctioning key fobs. The LR43 batteries are much cheaper than the LR44 cells. The hole required to make the project is now shallower, so you can theoretically use thinner materials, reducing your cost and also the time to manufacture. And there are no fidgety sponge or cardboard separators required. So all in all, it makes for a very tidy project, and we've certainly found it very useful in our school.